Okay, picture this scenario. A user's laptop goes out for a standard hardware repair. Maybe it just needs a new motherboard. It comes back, the user powers it on, and instead of seeing your company's beautifully customized sign-in screen, they're staring right at a generic, plain vanilla Windows setup screen. There's no automatic enrollment, no apps installing. It's just the standard consumer out-of-box experience. So, as an IT engineer, you do what we all do. You immediately go check Intune. And look at that. The device is still there, the serial number matches perfectly, everything looks completely fine on the surface. But, well, it's not. What you actually have on your hands here is an orphaned device. It totally exists in your records, sure, but the Windows Autopilot service, it no longer has any idea what physical machine is sitting on that desk. Welcome to this explainer. Today, we're going deep into the back-end architecture of Windows Autopilot to figure out exactly why this happens. Consider this your premium consultant runbook. We're going to demystify the hardware hash, look at the exact registry keys and event logs that prove what's broken, and give you the absolute authoritative 6-step process to get these devices back under management. Let's get into it. Okay, let's dive into this and map out our game plan. We'll be hitting 6 key areas today. 1. The orphaned device problem. 2. Inside the hardware hash. 3. Which repairs break Autopilot. 4. Verifying the device state. 5. The 6-step fix. And wrapping up with 6. Validating the resolution. Starting off with Section 1, the orphan device problem. Now, you might be wondering, why on earth didn't this repaired device enroll? It is literally the most common question you'll ask yourself when a machine lands back on your desk. And the deception here, it lies entirely right there in the Intune console. If you look the device up by its serial number, it's still sitting right there in your device list, looking totally healthy. But here's the catch. That serial number is simply the one they recorded when the device was first registered. It tells you absolutely zero about whether Autopilot can still recognize the physical machine right in front of you. Trusting that list without digging any deeper, that's going to cause an enormous amount of wasted troubleshooting time for you and your team. And this brings us to the visual proof. The expectation, obviously, is a totally seamless zero-touch deployment. The user powers on the machine, connects to Wi-Fi, and boom, they are immediately presented with your company-branded OBE login. But the frustrating reality of the orphan state is that generic setup screen. It's sitting there asking for a personal Microsoft account or having you pick keyboard layouts like it's fresh off a Best Buy shelf. Autopilot simply doesn't know who this device belongs to anymore. Now, sometimes Intune does try to give you a heads up, but it's really easily misunderstood. In your Autopilot device list, the profile status column might suddenly change from assigned to fix pending or attention required. Microsoft's documentation actually notes that if you click fix pending, a message pops up saying a hardware change was detected and it's attempting to automatically register the new hardware. It basically tells you to just sit back and relax, you don't need to do anything. But in the real world, waiting rarely works. If that status lingers, the automatic recovery has officially failed, and you're going to have to intervene manually.
Moving on to Section 2, inside the hardware hash.
Now, what's really interesting about this slide is that it busts what is arguably the biggest myth in modern endpoint management. The hardware hash is not a static serial number. Not at all. It is this massive dynamic block of text. A lot of folks call it the 4K hash because, well, it's roughly 4,000 characters long. It's essentially built from a bunch of hardware and firmware identifiers mashed together. The SMBIOS UID, the MAC address, the disk serial number, the whole shebang. But here's the kicker. It embeds a timestamp. That means the hash looks different every single time you read it, even if you never touch the machine. Because it constantly changes, Autopilot isn't looking for a perfect text match. It's using a matching tolerance algorithm up in the cloud.
Because of this, you will inevitably stumble across blog posts out there claiming they can decode this hash byte by byte for you. Be incredibly skeptical of that. This quote here is Microsoft's official stance on the Dev Detail Configuration Service Provider, or CSV, which is the backend technical interface that actually exposes the hash. They explicitly state it is a raw blob that is not meant to be human-readable by design. Any third-party tool claiming to decode it is just relying on reverse engineering, which honestly can silently break the second Microsoft decides to tweak their algorithm. So, rule of thumb, never ever build your compliance or asset tracking processes around a decoded hash.
Now, before we look at what does break the hash, let's clear up a massive misconception that I see creating so much unnecessary work for IT teams everywhere. Reinstalling or wiping Windows on a device does not break its Autopilot registration. Why? Because Autopilot registration lives exclusively in Microsoft's cloud service. The device's identity, that lives locally in its physical hardware and firmware. Wiping the local hard drive doesn't touch either of those things. The setup profile is just downloaded fresh during OBE, applied, and then discarded. So please save yourselves the headache. Stop deleting devices from Autopilot just because you're rebuilding the OS. All right, Section 3, which repairs break Autopilot? So Autopilot is actually pretty forgiving when it comes to minor hardware changes. Swapping out some bad RAM, dropping in a new battery, or even replacing the primary hard drive. That generally keeps the hash match totally intact. But a motherboard or a TPM replacement, that is absolutely catastrophic to the hash match. And here's why. The Trusted Platform Module, the TPM, contains a built-in private identity key. Even if your repair center perfectly copies your old serial numbers over to the new motherboard, they physically cannot copy the TPM's private identity key. It's impossible. Therefore, a new motherboard means a new TPM, which means Microsoft's cloud treats it as a brand new device. Period. End of story.
Section 4. Verifying the device speed.
So the crucial point here is confirming what the device locally thinks its status is. You do this by jumping into the Windows registry, specifically looking under HKLM, Software, Microsoft, Provisioning, Diagnostics, Autopilot. If you see that the CloudAssignedTenantID or the CloudAssignedTenantDomain are completely blank, well, this device isn't registered with Autopilot at all. It's flying blind. And if tenant matched is set to a 0, the user is absolutely going to get an error because the signed-in user's tenant doesn't match the registered tenant on file. These keys are basically your first local indicator that the cloud handshake totally failed. Next up, you're going to want to dive into the Event Viewer. Navigate your way down to Applications and Services Logs, Microsoft, Windows, Modern Deployment Diagnostics Provider, and just look right at the Autopilot channel. Event ID 908 is your smoking gun here. It explicitly states that there is a serial number or product key mismatch between what's on file in the cloud and the physical hardware sitting on the desk. Event 171 points straight to a TPM identity issue, which is classic post-motherboard repair behavior. And if you see Event 163, it just means the device didn't even bother trying to download a profile because an old one is already cached. For that one, you just need to run a quick system reset or sysprep to clear it out. All right, Section 5, the 6-step fix. So Microsoft's fully supported path for handling a motherboard replacement requires these 6 exact steps. And let me be clear, the order here is absolutely critical. First, you have to delete the device object from the Intune admin center. Second, remove it from the Autopilot devices list to fully deregister it. Third, complete your physical repair and meticulously verify the firmware. Fourth, capture a brand new, fresh hardware hash from the running operating system. Fifth, re-add the device into the portal by uploading that new hash. And finally, step 6, reset Windows back to OOBE so it can pull down the brand new setup profile. Skipping any of these steps, or doing them backwards, it's going to leave the device unrecoverable. And this brilliantly illustrates where most deployments actually fail. Even if you follow the steps, these gotchas will completely trip you up. Step 3 relies heavily on your repair vendor. If they install a shiny new motherboard but fail to inject the proper manufacturer, model, serial, and a digital product key into the BIOS, Autopilot will just flat out refuse to register the new hash. Honestly, you need to make firmware correctness a written requirement in your repair contracts. Also, when you're running that PowerShell script to capture the hash, you must always use the -output file parameter. If you try to manually redirect the output using standard command line brackets, it actually corrupts the CSV format. Lastly, when you upload that CSV to Intune in Step 5, you have to leave the serial number and product key columns completely blank. Including the old data there will instantly trigger a ZTD device not found error. And finally, Section 6, validating the resolution. You're going to want to validate that the fix worked through 3 independent checks. First, check the Intune console. The Autopilot device record should clearly, without a doubt, show assigned as its profile status. Second, go check that Autopilot event log again. Those 908 mismatch errors we talked about earlier, they should be totally gone. Instead, you're looking for event ID 153, which reports that the internal state changed to profile available, and event ID 161, confirming the settings retrieved successfully. That right there is the beautiful sound of a quiet, healthy event log. And for the third check, there is a really excellent automation opportunity here. Instead of checking all of this manually, you can just use a companion PowerShell script created by Imran Awan, which is freely available over on GitHub. This script queries the Graph API and your local CIM instances to give you a complete, read-only report on the hash and all its matching attributes. And the best part? By default, it masks all the sensitive identifiers, making it perfectly safe to attach directly to your support tickets without leaking your raw 4K hash to anyone. It's going to immediately flag if crucial firmware fields are missing or if those identity errors are piling up in the background. So, there you have it. You now understand the incredibly dynamic nature of the hardware hash, exactly why those motherboard repairs break your enrollment, and you possess the ultimate 6-step runbook to fix it right the very first time. Are you ready to confidently fix your orphaned Autopilot devices? Take this knowledge, apply it in your own environments, and definitely challenge your repair vendors to get their firmware injection right the first time. After all, what if your next quote-unquote broken device isn't actually broken at all, but just suffering a massive identity crisis up in the cloud? Think about that the next time you have to rebuild a machine. If this explainer helped you untangle a messy deployment, make sure to hit subscribe, and hey, let us know your absolute worst hardware repair stories down in the comments below. Keep learning, keep automating, and we will see you in the next one.